to the US Open. Today we will be exploring the physics behind one of the greatest sports to have ever existed. First, we'll be looking at how the F equals ma equation relates to a player's serve. We can find the force of the racket hitting the ball by multiplying the mass and estimated acceleration of the racket. Now we'll head over on court to Sydney to check out the latest physics concepts.
Thanks, Caroline. Now let's see how this player's serve translates into velocity versus time. As you can see from this lovely graph right here, the velocity of the ball is increasing over time. We can also calculate the displacement of the tennis ball as it travels through the air by using the equation 1/2 base times height in order to find the area of the graph beneath the line. And then check out this acceleration versus time graph. This shows us how the ball has constant acceleration after making contact with the racket. Back to you, Caroline.
Thanks, Sydney. Now let's figure out how much work is being done by the player. By multiplying the force being applied to the ball by how far the ball travels, otherwise known as displacement, we can figure out how much work Jackie is doing when she hits the ball. We can also figure out the kinetic energy of the ball. By multiplying 1/2 times the mass of the ball as well as the velocity of the ball squared, we can calculate the kinetic energy of the ball as it moves through the air. Now let's go back on court with Sydney and professional tennis player Jackie.
Thanks, Caroline. Now let's take a look at elastic collisions. Wow! Did you see that? Look at how the ball compresses when it hits the racket before bouncing off. This is called an elastic collision, when two objects collide and bounce off of each other. It is also possible to calculate the velocity of the ball after impact by using the equation m1 times v1 plus m2 times v2 equals m1 times v1 final plus m2 times v2 final, where we multiply the mass of the ball by the initial velocity and final velocities in order to find the velocity of the ball after impact. How cool! Back to you, Caroline.
Thanks, Sydney. Now let's talk about Newton's second law. This law states that in the presence of a net force, an object will experience acceleration. Now watch the ball closely as the player hits it. Do you see how it gets faster after it is hit with the racket? This means that the ball is accelerating after it experiences a net force, otherwise known as the racket. Now stay tuned for an exclusive interview with the professional herself.
I'm here with professional-ish tennis player Jackie. Now Jackie, tell me, how do Newton's third law apply to physics?
Well, Sydney, Newton's third law says that for every force, there is an equal and opposite force. When I'm volleying, for example, if I hold the racket really loosely in my hand, you can see that when the ball hits it, it bounces off. The racket moves in the opposite direction.
Wow! That's amazing! Thanks for the great explanation, professional tennis player.
Well, that's the physics behind tennis, folks. Thanks for watching, and join us next time for the physics behind croquet.